Module 1, Section 7, Objectives 1, 2, and 3. So 1 says to understand various ways to symbolically write division. 2 is modeling interpreting division, and 3 is writing division as repeated subtraction. Okay, this page has 4 different versions of divide problems shown different ways. Okay, and it says to solve each one, show your thinking using objects, drawing, or diagram. So I'll show you different methods possibly on different ones, and we'll see what we've got here. So let me get a few things drawn in, just a sec. Okay, they're not very neat, but each dot represents an apple in each of these problems, okay? So on the first one, if 24 apples are put into boxes with 8 apples in each box, how many boxes are there? Okay, so we could start with a box and put 8 apples in it, which means take up 2 rows. Okay, so then we take another box and put 8 apples in it. So that's another 2 columns, rows, whatever you want to call them. Third box, 1, 2, 3, 4, 5, 6, 7, 8, and that uses the last 8. Okay, that's one way of looking at it. My bet, though, is you probably did something like this. You group those into 8, or a different 8, but you're just grouping them into boxes this way, right? So we have 3 groups, either way, 3 boxes or 3 groups. So how many boxes are there? 3. So this next one, we could do it the same way. We could do 4 boxes in that one, or 4 apples in that box, 4 in this one, and just keep going until we have 32 apples, right? And I haven't gotten that far yet. And the reason I know this is because I know the answer. And you probably do too. It's going to need 8, right? Okay, so I just keep putting apples in boxes 4 at a time until I run out of apples. Or I can group them up 4 at a time over here. And I would still need, that was a nice one, 8 boxes, right? Okay, C. If 20 apples are packed into 4 boxes, with each box having the same number of apples, how many are there in each box? Okay, so now we're going to have 4 boxes, and I want to put apples in each one so that's an even number. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there would be 5 in each box, right? Okay, so over here, grouping it like I've shown you up on the other 2, they're packed into 4 boxes. So I want to take what we have here and divide it into 4 equal groups. And because of the way that I've drawn it, we can do 1 row at a time. So those are going to be our boxes, right? And you can see there are 5 apples in each one. And D, 36 apples packed into 6 boxes. So we could do 6 boxes this way, and we want to do them equally. So basically this is like dealing cards. You just want to deal 1 to each player, or 1 apple to each box until we have as many as we need, right? So right here we have 4 in each box, and there are 6 boxes, so we only have 24. So I've got to keep going. 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So 6 in each, right? So over here we could break it into 4 equal parts, and because of the way I have it drawn, each row is a different part. Okay, so the question at the bottom, what is the same and what is different about the way you solved A and B compared to C and D? Okay, I'm going to put A back up here so we can see. We did 1, 2, 3, 4, 5, 6, 7, 8 in the first box, and then 4, 5, 6, 7, 8 in the second, and 1, 2, 3, 4, 5, 6, 7, 8 in the third, and then we run out of apples. Okay? So the first two, you grab a box and fill it up. Grab a box, fill it up. Grab a box, fill it up. Same thing with this one. You grab a box, fill it up all the way through until we have all 8 boxes full, or until we run out of apples and we know we have 8 boxes. Now the next one, we set out our boxes first, and then we added apples one at a time to each of them so that we kept them even, right? It's like we dealt the apples to each of the boxes. It's the same process. Try it again. It's the same answer, just a different process. So for this one, problem B, Anthony showed grouping the 4 apples from the first box, 4 apples for the second box, and so on until he ran out of apples. So doing this way, he filled 8. And we did one like that, so you saw that. But let's take a look at it this way. If he started with 32 apples, and then he took 4 away and put 4 into the first box, so now he has the first box and then 28 more. You take 4 and put it into the next box, and you have 24 left. Take 4 of these and put them in the next box, put 4 of those in the next, etc., all the way down. You can see how our number of apples left is dwindling, right? You start with a big pile of 32, and you keep taking 4 away, all the way down until you have nothing left. Okay, that's what this is saying right here. This is called repeated subtraction. Okay, so multiply was repeated addition, exponents are repeated multiply, and division is repeated subtraction. Okay, so instead of writing minus 4, minus 4, minus 4, minus 4, minus all the way down, you're going to divide. And here are the vocabulary words, if you will, for a divide problem. So we have the dividend is the number that you start with. So this was the number of apples we began with. The divisor is what you're dividing by. So this was how many boxes we wanted to divide the apples into, or we wanted groups of how many apples, so how many boxes did we need? And the quotient is the answer. Okay, so the answer to a divide problem is the quotient. The dividend is what you start with, and the divisor is the number you're dividing by. And then the definition of subtraction, try it again, division itself, is finding the number of groups, or finding the size of each group when we share into groups of equal size, or it can be thought of as repeated subtraction. Okay, there are several ways to represent division, to write out a division problem. Okay, so all of those 4 that you see here, 2, 3, 4 different versions, mean 32 divided by 8. May not look like that, but that's exactly what it means. 32 divided by 8, 32 divided by 8. This one's kind of backwards. You start in the middle underneath the thing, so 32 divided by 8. And this one is basically the same as this one, but written on an angle. Okay, now that last one, I want you to get used to not ever using a diagonal fraction. Okay, and your written work on a calculator, keyboard of some kind, you most likely will have to type it in that way, because you have a 3 and then a 2, and then that means divide, and then your 8. So typing it, that makes sense. But when we get into higher level algebra problems, it's going to be more confusing to do it this way. So let's not do it that way ever. So I'm going to kind of skip over that one whenever we need to, because it's really important not to do it that way. It's true, and it does mean divide, but I want you to get used to now not using it, okay? So 32 is the dividend, and 8 is the divisor. And then the letter R, or capital, is often used to indicate there is a remainder. Sometimes you will make the remainder into a decimal or into a fraction, but if you want to write it just as a whole number, that's what it means. Okay, so let me show you an example of what the remainder looks like. Okay, so there I have 14 dots. I'm going to do this problem right here. And I want to divide it by 3, which means I want to see how many groups of 3 I have. Okay. So I have 1, 2, 3, 4, and 2 left. Okay, so your answer is 4, remainder 2. Okay, so the 2 are the extras, the leftovers. That's what a remainder means. Okay, and lastly on this page, right here, this is incredibly important. Multiplication and division are they're inverse operations, so they undo each other. You check a multiply problem by dividing, and you check a divide problem by multiplying. Okay, this example is an absolute mess. Okay, so part of the problem is there's an extra problem kind of written in the middle of all of this. So subtracted 6 times, here's your this part and this thing. None of those belong in this problem, and that's there. So I rewrote this problem on the next page with just the parts that we need, and then we'll do it ourselves, okay? So it asks you to rewrite the division problem 3 other ways, but I'm going to say 2 because I don't want to use the diagonal. And then identify the quotient, the dividend, the divisor, and the remainder if there is one. Okay, so first of all, let's rewrite them. Okay, knowing how to go back and forth between the different ways of writing things is incredibly important. Okay, so if we start 12 divided by 3 equals 4, let's write it this way. Okay, so we have 12 divided by 3, and that's equal to 4. Okay, now when we write it as a fraction, the 12 is on the top and the 3 is on the bottom. So that's 12 divided by 3 equals 4. Okay, now the second one, we start with this version and we're going to change it to the other 2. So let's do a fraction next. 42 divided by 7, and the answer is 6. And now straight across, you're going to use 42 divided by 7 equals 6. Okay, next problem here. Okay, we're going to do, let's do straight across. So 27 divided by 4 is equal to, now this whole thing is your answer, 6, remainder 3. Okay, so 27 divided by 4 is equal to 6, remainder 3. Okay, now this last one, I'm going to do it all 3 ways because it's the incorrect version. I shouldn't say that. It's the non-used version. There you go. So let's do all 3 of the others. Okay, so first of all, 20 over 9. So rewriting the fraction as a horizontal fraction bar instead of a diagonal one. And you have to use a capital R? No, you can use lowercase, capital, it doesn't matter. Okay, and then 20 divided by 9 equals 2, remainder 2. And 9 goes into 20 2 times with 2 left. Okay, so now we need to go back and identify the quotient, the dividend, the divisor, and the remainder. Okay, so let's say the quotient. Quotient is the answer. All right, I'm going to make the writing a little bit thicker here. So the answer is right there. Those are all the quotients. Okay, on this one, the answer is 6. So those are the quotients. On the next one, it's 6 remainder 3. The entire thing is the quotient. And same thing with this last one. 2 remainder 2 is the quotient. Okay, so whatever the answer is, that is the quotient. Okay, now let's change color here, the dividend. The dividend is the number that you start with before you start breaking it into groups. Okay, so that's the 12. So you notice the 12 comes either first, underneath, or on top. Okay, so there's underneath, top, and first. Underneath, top, and first. Underneath, top, oh that was horrible, and first. Okay, and then the last one, well, not the last one, I apologize. The next one is the divisor. Okay, so the divisor is what you're dividing it by. So the number of boxes if you're dividing apples up. Okay, so your dividing by number is there. Okay, in general, you know, with normal whole number problems, your divisor and your dividend, try it again, your divisor and your quotient will be smaller than the dividend. Okay, the number you start with is going to be the big number. Okay, and then one last one here. We need to figure out the remainder if there is one. And that's easy because it comes right after the R, right? Remainder, 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 remainder. Okay, so the first two, so this one and this one, there is no remainder. So remainder 0, you will never see that. You're just going to have it plain like 4 is your answer. It's not 4 remainder 0. Okay, this is showing how to use a number line to represent the repeated subtraction portion of division. Okay, so if we start with 12 divided by 2 equals 6, we know that's true. This is what it looks like on a number line. Okay, so you're going to start at 12, and then you're going to go down 2. Okay, 2 spaces. And then 2 more spaces, 2, 2, 2, 2. So how many hops did we take? There's 1, 2, 3, 4, 5, 6 hops. So it took us 6 jumps of 2 to get back down to 0. Okay, let's do another one. This is what a remainder looks like if we do the same thing. Okay, so original problem, 17 divided by 5. So we're going to start at 17 and then go down 5 spaces at a time. So 1, 2, 3, 4, 5 spaces. So there's 1, 1, 2, 3, 4, 5. There's 2, 1, 2, 3, 4, 5. There's 3. And if I went down 5, I would pass 0. And you don't want to do that. Okay, so we're going to consider these last 2 spaces are the remainder, the extra, the ones that are left over. Okay, so 17 divided by 5 is equal to the 3 jumps that we made and then the 2 left. So 3 remainder 2. Okay, here's a couple more examples, and we'll do 2 over there. So really quickly on theirs. You start at 6 because that's where your dividend is, and then we're going to count down 2. So 1, 2. There's your first hop. Down 2. There's your next. Down 3. Try it again. Down 2, and there's your third. So we have 1, 2, 3 jumps. So our answer is 3. Okay, this next one, we start at 8, and we're going down by 3s. So I'm going to do it just a little differently here. I'm going to go 1, 2, 3. There's 1. 1, 2, 3. There's 2. And now I can't go 3 because I go past 0. So that means these 2 are my remainder. So I have 2, and then the remainder is the number of leftovers you had, 2. Okay. So here we go. There's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And we want to go down 3 at a time. So we're going to go 1, 2, 3. There's 1. 1, 2, 3. There's 2. 1, 2, 3 is 4. 1, 2, 3. Whoa, it's not 4. It's 3. Hello. Is 4. Yes, I can count. I was getting the answer in my head instead of the next bump. Okay, last one here. Counting to 15. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, and we're counting down by 2s. Okay, so I'm just going to go skip 1 and get to the next one. So there's 1, 2, 3, 4, 5, 6, 7. Now if I go 1 more, I'm past 0, right? So I had 7, and then let's undo so we can, there we are, 7, and then this 1 right here is our remainder. Okay, so 7, remainder 1. Okay, on this one, Benny has 18 cookies he's packing into bags, and he wants each bag to contain 6 cookies. Okay, so let's keep reading it all the way to the end. How many bags of cookies will he have? Draw a model or a number line to represent how to find the number of bags of cookies. Use base 10 blocks or counters if needed. Write a division equation to represent the situation and be ready to discuss your ideas. Okay? Personally, I bet you don't use number lines, right? So I'm not going to do it that way either. Okay, so let's put 18 cookies up here. I'm going to count by 5s. Well, rows of 5, that is. So there's 10, 15, 16, 17, 18. Okay, these represent those pink frosted cookies. Okay. Now, we want to put 6 cookies in each bag. Okay, so I'm going to group 6 at a time. Okay, so it doesn't matter how I do it? Not at all. Okay, so there's 6 right there. There's 6 here. And there's 6 here. Okay, so we need 3 bags, right? What if I group them this way? That's fine too, isn't it? 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Sure, doesn't matter as long as you have 6 in each. So we need 3 bags. And our equation is going to be 18 divided by 6 equals 3. Okay, not too bad. If I did it on a number line, just to show you. So 0, and we want 6 cookies in each, so that means we're going to go 1, 2, 3, 4, 5, 6. There's our first. 1, 2, 3, 4, 5, 6. There's the second. So far we've filled 2 bags. 1, 2, 3, 4, 5, 6. There's our third bag. Okay? It's kind of interesting seeing it on a number line, but may not have ever thought about it that way, huh? Okay, so example 3, there are 27 students that need to be split into 7 rows. How many students will there be in each row? Will there be any students left over? Draw a model or a number line to represent it. And then solve. Sorry, forgot that part. So what I'm imagining is like a seating chart of sorts. Okay, and we need 7 rows. So 1, 2, 3, 4, 5. I'm not going to have enough space. 6, 7. And we need to, I'm not going to put anything else in it yet. Okay, so I'll show you. Here we go. So 27 students. So there's 1, 2, 3. Actually, let's do X's. It's faster. 1, 2, 3, 4, 5, 6, 7. There's 1 row. And, well, 1 in each row, excuse me, right? So there's 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Is that right? Okay, so let's draw in the rest of the boxes here and then answer the questions. So 27 students need to be split into 7 rows. Okay, we did that. How many students will there be in each row? Will there be any leftovers? Okay, so if you're talking about full rows and not partial rows, you can see there will be 3 students in each row. And then there will be 6 left over. Okay, so the leftovers are the remainder, right? And this particular problem has a typo. It says 7 divided by 2, and we have 2, 4, 6, 8, 9 divided by 2. So let's get rid of one of these so we can actually work the problem out as it is written. Okay? All right, so now we have the 7 dots, and you can see we're grouping them 2 at a time. And we have that one left. Okay, so we have 3 groups, 1 left over, so it's 3 remainder 1. Okay, on B, let's get some dots out there. I decided to go a little bit more random this time, so you have to work a little bit more. Probably would not do that. You'd probably put them in rows, but that's all right. So we want to group them in groups of 4. Okay, so there's 4. Here's 4. There's 4. And there are 4 left. So it goes on evenly. The answer then would be 4. 16 divided by 4 is 4. This one says write your own scenario. You can if you like, but I'm not going to require it. The idea is you start with 15 and you want to group them either 5 in a group, so how many groups are there? Or you start with 15 and you have 3 groups. How many are in each group?